Okay, you're on page 32, right? I know I know it went a little longer than I would have liked it to be, but that's okay. I hope you learned something from it. We need to remember, way at the top here of page 32, complementary. Think of a 90-degree angle. It's right to complement someone, right? Hey, there. And supplementary, you should think of 180. Think of a hat. I don't know. 180 and this is 90, right? So it could be that I ask you what the difference is between them. So complementary, the angles will add up to 90. Supplementary, the angles will add up to 180. Often you will encounter a problem, right, where the angles are outside the triangle. Okay. Page 32. You should try to find a straight angle or a right angle to possibly find an angle inside the triangle. Okay, so sometimes it will feel as though you don't have angles, but you can easily find an angle inside the triangle. Okay? So the classic ones are north, south, east, west scenarios. So please, with me on the right side here, just have a reminder, right? North and south, they're perfectly vertical, and east, west are perfectly horizontal, and they meet at a 90, right? All around. Okay, so here we go. The captain of a boat sees 2 points on land. So here's the boat, right? And there's 1 point there, and the other point is right there. And the points are 2.5 kilometers apart. That is already in the diagram, but be mindful, I will start doing this. I will start taking away numbers from the diagram, and you have to add, right, based on the question. And so it says 1.8 kilometers east of the boat, right? So if this is your boat, this is straight east, right? So we'll go east here. And I don't know, have you ever heard of bearing? Like if somebody gives you directions using bearings, have you ever heard of it? Go ahead. I thought you would have heard of bearings. But bearing is always a 0-degree bearing. If you go 0 degrees, it's perfectly north. Right, so this would be a 0-degree bearing, which is north. If you navigate, right, if you're a captain of a ship, you definitely would know your bearings, right? And so if it's a 12-degree bearing, right, that means that if you shift from north, you go 12 degrees, move it that way, and that's your direction that you're headed. Okay, so you have your triangle. I usually use green. This is your triangle. There. You have no angles inside, right? No angles inside triangle. But there's a 90 there. You see it? The north and the east line, they form a 90, like a box like that. And maybe on the north here, you do the same color. North and east lines meet at a 90. So what is angle B really? This angle right here on the inside of that triangle, we'll just say, well, we have 90 altogether, and we will subtract 12 degrees from it. Does that make sense what I just did there? I took that 12 degree away from 90, and that leaves me that little sliver here. I'll be right with you, Kenneth. Just give me 1 second here. I need to highlight this part right here, this little chunk, because that is angle B, which I'm going to find to be 78 degrees. Yes, Kenneth, go ahead. Yeah, there are various ways to do it. This is going to be the way I'm going to show it. Yeah, we can talk. we can talk. Yeah. So this is your B here. That's the angle that we just found. This is 78 now. Without messing it up too much, I'm going to go 78 there. Okay. So now you have, this is now inside triangle. That's all, guys. That's all. You're just using that property to find an angle inside a triangle. Okay. So now let's draw this here. Conveniently, they're using ABC, right? This is 78. This is 2.5. This is 1.8. What are they asking me for? How far is the boat from point? Oh, wait, I got this wrong, eh? Wake up, wake up. This is B, this is A, sorry. How far is the boat from point A? They're asking me for this side right here. That's the question mark. So what does this mean? Which law? Sine law. Yes. Did I tell you that most of the time you'll be using sine law, right? 70 to 80%, that's just how it goes. Don't ask me why. That doesn't mean that you will not have cosine law problems. You will have cosine law problems. Can I solve for side x just like that? As it stands, no, right? What is the only thing that I can do right now? I have this side which allows me to solve for that angle. So I have to do that first. So watch this. I'm going to go sine of A over 1.8. Okay. So I will say that sine of A is, so this is a multi-step question. This isn't just a slam dunk, just one setup and you're done, right? Let's figure out what this is. I want to make sure we finish today this example in particular. So I'll tell you that this is 0.7042 ... right? So angle A is sine inverse of that. So just make sure you write this down, okay? And you have 44.77 as your angle there. Let me just move this down. So I like to show what I did here. This here would have been step number 1. This here, what I just did, is what I would call step number 2. Can I now find angle C, which is, right, angle C, this angle is across the side that I ultimately want. So yes, I can find angle C. I'm just going to go 180 minus the 78 minus 44.77. And that's 57.23. Underline that because it's important. That's step number 3, basically. And now, I used up way too much room for the other one, right? That's okay. Sine of 78 over 2.5, that's the pair I knew right from the get-go. And now I'm going to use sine of 57.23, right? The angle I just found, which is across side x, which is the ultimate question. So you go cross multiply 2.5 times sine of 57.23 divided by sine of 78. X is 2.15 kilometers. This is the ultimate question that I just answered. Distance from boat to point A. I'll do this. Homework, page 36. There's one question there that I want you to try. Not today. We won't have time. I just want to wrap this up before we go. So multi-step. This one is a multi-step question. It wasn't just a slam dunk once and done, right?